Hello, my name is Lindsay McPhee, and for my term report video, I'm going to be talking about Kamiak Butte and the foundations that brought us to today. We'll be starting 100 million years back and work our way into how this history develops the land we know today, as well as species of birds that can commonly be found. First up is the history of Kamiak Butte. Before Pullman became the city it is today, the Pacific Northwest underwent over 500 million years of geologic change. Entire continents drifted across the globe, ice ages came and left, and volcanic eruptions were numerous. Until approximately 100 million years ago, the entirety of today's Pacific Northwest was completely underwater. The theory of continental drift, or today's plate tectonics, described the process of how the mantle layer plates subduct, diverge, and slide past each other, moving our continents around the globe. Because of this, continents are constantly and slowly drifting. Offshore, approximately 400 miles west of the Palouse, lies the Cascadia subduction zone, where the oceanic plate dips below. Here, 50 million years ago, the land of the Pacific Northwest began to compress and uplift out of the ocean. As it compresses, the oceanic material pushed, pressurized, and heated so deep in the mantle that it begins to spill out, creating the Cascade Mountain range we know today. This pooling of magma continued until 17 million years ago, when the pressure within the hotspot grew to be too great. For the next 10 million years, molten basalt lava flowed across the Pacific Northwest. This covered Washington, Oregon, Idaho, Nevada, and California for over 63,000 square miles and up to 2 to 3 miles thick. The Columbia River basalt buried everything in its path. Now, the Palouse has a layer of quartzite rock covered by the layer of basalt. Over 99% of the basalt flooded in this time, transforming the landscape completely. The one thing, however, that did not get buried by the basalt was Kamiak Butte and other quartzite buttes, the points tall enough to not be completely covered. As time passes, the climate begins to cool, and natural humidity, lakes, and ocean water has accumulated in a glacier formation through the Pacific Northwest. Glaciers move similarly to rivers, but in much slower physical motion. Density and pressure bring the glacier downhill, bringing any debris along the way. Glaciers slowly melt and freeze, moving across the land for millions of years, before finally entering a period of melting and breakage about 11,700 years before present day. As the flooded brown water backed up, the water came to a standstill. As the fluidity of the motion stopped, the sedimentary component sank down and settled onto the land. As the water filtered out and drained, the muddy sediment was left behind to dry into silt. Maritime polar air systems, moist ocean winds traveling from the Pacific Ocean over the Columbia River Gorge and out east begin to pick up the sediment left behind. Soil particles fill their clouds, getting trapped within the currents. At a particular size and weight, sediments are dropped from the atmosphere and gently layered down to Earth. This transitions into the use for loess soils and the land of the Palouse today. Loess soil is the most productive wheat-growing material in the world. Loess soil gives the Palouse its characteristic wind-blown hills. When water falls, it drains quickly through the loess soil before halting at the layer of basalt. The nutrients within the water accumulate here, providing exceptional hydration and nutrition to plants with roots. However, when water overtops the quartzite-based sediment, for when the Palouse was the ocean shoreline, it passes through quickly before it can be absorbed. This is why the loess soil in the Palouse is only great at growing crops and why quartzite buttes aren't. Kamiak Butte is divided into two halves, the north-facing and south-facing aspects based on their widely varying environments. The north-facing aspect is much more protected. Facing away from the wind and receiving much less direct sunlight, the north-facing aspect is appropriately shaded to allow more species to thrive. Plants can still receive sunlight without as much of a drying effect. Water melts more slowly, saturating the ground more thoroughly. This environment provides ample resources for trees such as Douglas fir, ponderosa pine, and the occasional western larch. Grasses also share the land, species such as Idaho fescue, Sandberg's bluegrass, and blue bunch wheatgrass, as well as the invasive North African grass. On the south-facing aspect, sunlight and wind are more direct, making for a much different environment. Here, forest fires are much more common as the arid grasses can spark easily. Quartzite rocks are still common, marked orange in tons of iron oxidation and weathering from the exposure. Kamiak Butte's geographic position, topography, and subsequent vegetation are important aspects in the accumulation of speciation for both plants and animals. Both abiotic and biotic features are responsible for the determination of what can survive. This video focuses on the species of birds that routinely call Kamiak Butte and the surrounding area their home, as well as identification factors for determining the most observed species. Over 140 species of birds alone have been reported at Kamiak Butte. However, for the sake of brevity, we'll focus primarily on the top 5 spotted birds as according to eBird, a public reporting domain for birdwatchers. The 5th most spotted bird at Kamiak Butte is the dark-eyed junco. They belong to the junco variation of New World sparrows, commonly found across North America in forested conifer habitats, flying in flocks. Junco vary in coloration, but some of their traits stay consistent across specific species. At Kamiak Butte and the surrounding area, junco are typically slate gray in color. Their bills are a pale pink or white and have white outer tail feathers that spread as they take flight as their most defining trait. These are foraging birds, meaning they mostly hop and run along the ground to find seeds of grasses and weeds, as well as insects and bugs to eat. The 4th most spotted bird at Kamiak Butte are Wilson's warblers. Wilson's warbler are one of the smallest of the warbler species and found throughout Canada and the West Coast. Wilson's warbler are characterized by their bright yellow coloration. Males have a distinctive black cap on their heads, and females are similar but vary in their black caps. They fly restlessly through perches within the understory of the forest, grabbing flying insects or picking them from the foliage of the trees. They prefer flying and hopping low in particularly open areas, such as the south-facing aspect of Kamiak Butte, as opposed to the denser forest, such as the north-facing aspect. The 3rd most reported bird around Kamiak Butte is the Canada goose. These are one of the most easily recognized waterfowl birds. Characterized by their typical V-formation flying pattern, they can be recognized even in flock flight. These birds have adapted to civilization, allowing themselves into largely human spaces such as parks, neighborhoods, and golf courses. They're easily identifiable. Their long black neck is marked with a trademark white chin strap and a gradient gray body. Canada geese are less selective on the food that they choose. They can feed on a wide variety of plant material, from the shoots of grass to aquatic plants to cultivated grains. These birds aren't found directly on the butte, but in the surrounding wheat fields near bodies of water. The 2nd most spotted bird at Kamiak Butte is the European starling. An invasive species, they were brought to North America in the late 19th century as Shakespeare fans in New York wanted to see representation of the animals in his works. Now, they're one of the most common birds in North America, competing with native species for resources, destroying crops, and adapting well to wherever they are. During their breeding season, male starlings use their inept mimicry to impersonate other songs perfectly. In winter, they're covered in bright white spots contrasting their normally dark coloration. In summer, the spots disappear and their coat is dark, glossy, and somewhat resembles an oil spill sheen of purple, blue, and green. European starling also have a genetic advantage concerning their food. With a highly evolved sense of taste, they're able to differentiate taste between sweet and salty, and specifically between citric acids and tannins in fruits and nuts. Because some foods that are particularly high in tannins can be toxic to birds, this is an advantage to their ability to survive. They can also specifically determine the differences between different forms of sugar, such as sucrose versus fructose. This is especially helpful as they can't actually digest sucrose. This prevents the starling from eating something toxic or inedible before they can consume a toxic amount. The most spotted bird at Kamiak Butte is the red crossbill. They belong to the finch family and travel in nomadic flocks. Red crossbill have a specialized bill shape allowing access to its necessary food. Since they primarily feed on the inside seeds of conifers, their bill shape allow it to work it like a tool, prying open the tight cones. The red crossbill is so dependent on the seeds of conifers that its entire migration is based off of where it can find them. Once it settles, it's able to rear its young, also feeding them the same seeds. Here are the sources for the images used in the first section, used in the second section, and used in the third section. This is the work cited for the information stated in this video. Thank you for watching!